Hi, my name is Ibrahim Inusa from University Tananga National, Malaysia, and I'm going to present you our research paper entitled Digital Energy System and Data Privacy, a review of legal and ethical consideration in building and grid level applications. Our research paper has explored the integration of the digital technologies, where the digital technologies are reshaping the electricity productions, distribution, and consumptions. Our paper also explored the benefit and the risks of the digital systems in digital energies. How we see that despite the efficiency, reliability, and sustainability gain, major concerns raised around the data privacy, cybersecurity, and ethical responsibilities. Also, our research has explored the ethical consideration within the digital systems in digital energy systems, where we also explore the regulation gaps in digital energy systems, where we specifically focus on the GDPR and regional framework such as Malaysia PDPA guide for constant data protection and uses. However, those regulations framework their coverage of the real-time behavior of the sensitive data energy remain limited and inadequate. The purpose of our research has critically reviewed the legal and ethical issues in the data privacy across the building level and the grid scale digital energy systems. It identifies the risks, ethical challenges, best practices, and the key gaps would focus on the emerging digital energy landscape in Southeast Asia. Our study contributes to the debate and balancing innovation with the privacy, equality, and then accountability in global digital energy transition. At the overview of the digital energy systems, we explored the standard definitions of the digital energy systems, which include the digital energy systems uses the sensors, communications network, AI, and advanced data analytics to improve the energy, to improve how energy is generated, delivered, and consumed. Also included the key component that made the digital energy systems, which include the smart grid, Internet of Things, artificial intelligence, digital twins. But these technologies form the cyber-physical system that dynamically adjusts the energy operation, generate the large volume of the user-related data for forecasting and performance optimizations. We also compare the building level and the grid application systems to look at the overview of the digital energy system with these two components. At the building level applications, the digital systems operate at the building levels using sensors, IoT devices, and control platform to track, optimize the energy use in home, offices, and hospitals. While at the grid level application, the digital systems manages the power distribution networks, renewable integrations, and electricity vehicles charging. Also, we included the benefit, exploring the benefit and opportunity in digital energy systems, which include the efficiency and reliability, user engagement, predictive maintenance and sustainability. Risks to consider in these factors include continuous data collection and connectivity, introduce the legal and ethical concern, involve the cyber security, surveillance, and informed consent. Also, we look at the data practices in the digital energy systems, where the continuous data collection across the digital energy system, because these digital energy systems rely on continuous data collection at both the building and the grid level to improve the efficiency, flexibility, and reliability. Also, we look at the cyber legal frameworks and governance that were being deployed across the globe, focusing on the Southeast Asia, and looking at the common frameworks that were being developed. From among the cybersecurity risks that were being explored included that the cyber attacks such as the false data injection, denial of the services, and then replay attack can be manipulate or block the data, undermining the automated decision making and the system stability. However, the legal and ethical frameworks, the scholarly studies that we have reviewed highlighted the need for the legal framework such as GDPR to ensure the ethical, transparent data handling based on informed decisions. Misuse of the sensitive information through unauthorized access lead to leaks or commercial exploitation, threatening the privacy, systems integrity, and trust. The need for the integrated governance. Effective data governance requires technical, legal, and ethical strategies working together to protect privacy, support secure, accountable infrastructure. Also, at the legal frameworks overview that we look at included the challenges in the regulating of the data. However, the regulating the energy data become more challenging as the system they were more improved and they were deployed at the various levels. However, the frameworks such as EU of the GDPR of the California CCPA and Malaysia PDPA offer a general protection for the personal data. However, their application on the real-time behavior sensitive data from a smart meter building management systems remain limited and inadequate. So the key frameworks which were available to us at the disposal, most of us that they were referred or going back to the GDPR and the CCPA and the Malaysia PDPA and the Singapore PDPA. Those regions, they were always referred to those legal frameworks. And there are also gaps that we identify across those frameworks that we highlighted, which also the cross-border compliance. Also, we highlighted about how the regulatory conflict increases when the energy data crosses the judiciaries. For the example, the Malaysian system building data store on the Europe server raises a compliance problem under multiple privacy regimes. So we also look at the need for the energy-specific legal framework as a result of the identified gaps within the existing frameworks. Also, for the ethical consideration in the energy data ecosystems, we also look at the ethical importance in the digital energy systems, as the legal framework offers some protection, but ethical issues raised where regulations are unclear or lag behind the technology's development. As the data collections grows in smart building and grid infrastructure, ethical consideration on the data use, storage, and governance become increasingly critical. We look at the informed consent and the user awareness as important part for the strategy. Also, the data ownership issue, which contribute to the criticalness of the ethical consideration within the energy data ecosystems. Also, the fairness and the bias the fairness and the bias and inclusion, which are also part of the major challenges working with the machine learning algorithms and AI deployment in the digital energy systems, which also being the thing to be considered on building the ethical framework that will handle those gaps that we highlighted earlier. Also, the ethical design approach for such framework, we also highlighted the life cycles of how the previous and then the expected or the proposed should be informed. Then the context-specific ethical concern for the specific regions were needed because of the different backgrounds and the consumptions of those energies. Also, we look at the towards the responsible and context-aware energy informations or informatics, and this gives us how we should look at the rapid growth versus the slower regulation within the digital energy systems framework development. And also we look at how the fairness and inadequateness risks on deploying the framework. Also, we look at the balancing benefit and protection within the development of the framework. For that, a four-dimensional framework has been prepared based upon our research. And the first one will be legal dimension, to be handling the legal compliances, and then the ethical dimension, which will handle the ethical dimensions, and also the technical dimension, then the socio-cultural dimension. And these four dimensions to form the framework, a purpose of it provide the structured approach to access the risks and opportunity, help the researchers and the policymakers build the responsible and context-aware digital energies. Also, to our conclusion of our research, we included a comprehensive digital energy systems opportunities and challenges on a current trend, and also we provided the recommendation that the revised data protection laws to those frameworks which were already deployed to reflect the risks of the digital energy related data, new technologies developed to consider those in preparing the context-aware framework of the digital energy systems. Our paper also suggested the future research directions, such as current legal framework do not fully address the risks of the real-time behavior sensitive energy data. For that, the practical solution for the consent fairness and the data ownership remain limited. So the needed for the privacy and preserving yet efficient technical method, such as fairness-aware algorithm and the secure data sharing protocols, also need to be explored. Then few studies integrated the legal, ethical, and technical perspective. For that, the future work should adopt the cross-disciplinary approach and the regional case studies, especially in Southeast Asia, to able to further research should develop the participatory governance models and critical examine AI fairness, bias, and transparency to ensure that the system are not only efficient but also they were just and inclusive. Also, the contribution of our study included the links to legal and technical ethical consideration in digital systems and highlight the need for the regional legal alignment, especially in Southeast Asia, and emphasis that the context matter. Responsible innovations require ethical design tailored to the local governance needed and the regional conditional. So this is the paper that we have developed and presenting in this conference. Thank you again for listening. My name is Ibrahim Inusa, and you can connect with me via my LinkedIn, Ibrahim Inusa, or through my email, talk to ajmilala@gmail.com for research opportunities and more. And also we like to thank University Tananga National and University Technology Malaysia, UTM, for the academic and institutional support for this. I also like to extend a special thanks and appreciation to the supervisor of my study, Dr. Rina and Dr. Asmida, and also the co-authors of this paper for the continuous guidance and support throughout this research.